this is a winter air conditioning system which uses a preheater. Okay. So, let me begin at this point. Here you have outdoor air which is cold and dry. This certain amount of outdoor air is mixed with the recirculated air which is coming from the conditioned space. Okay, so the recirculated air from the conditioned space and the outdoor air are mixed, and the mixed air which is at condition M first flows through a preheater. Okay, this is a preheater. In the preheater, air undergoes sensible heating process. That means its moisture content remains same, but its temperature increases from Tm to T1. Okay, so only sensible heating takes place in the preheater. Now this heated air flows through a humidifier. In the humidifier, as the name implies, water vapor is added to the air. Okay, that means the moisture content of the air increases. Okay, so the humid air now flows through a reheater. Okay, so it enters the reheater at state 2, which has high moisture content, and this humid air flows through reheater where it is heated to the required supply air temperature S. So this hot and humid air, okay, hot and humid air flows through the conditioned space where it takes care of the sensible and heat losses from the building. Okay, so finally this hot and humid air leaves the conditioned space at state I, which is same as the state of the conditioned space. Okay, right, and this return air, some amount of return air is thrown out. This amount is equal to the outdoor air which is required for ventilation purposes, and remaining amount is recirculated. Again the recirculated air comes here, it mixes with the outdoor air, and again the mixed air flows through preheater, humidifier, reheater, etc. The cycle continues. Okay, so this is one typical winter air conditioning system which uses a preheater. The same process is shown here on the psychrometric chart. O is the condition of the outdoor air. As you can see, the temperature is very low. So here the dry bulb temperature, on this axis you have dry bulb temperature, and here you have the humidity. So the outdoor air is very cold and very dry. This is mixed with the recirculated air which is at the condition I. Okay, certain amount of air at this state and certain amount of air at this state, they are mixed. So the resulting air is at this condition M. Okay, so at this condition it enters into the preheater and it is sensibly heated from Tm to T1. Okay, so M to 1 is what happens in the preheater. So at this point it enters into the humidifier. In the humidifier, as I have already mentioned, the humidity of the air is increased. So it follows the process line 1 to 2, and this process path depends upon how humidifier is constructed or how you are adding the moisture. Okay, whatever it is, humidity increases in the humidifier from 0.1 to 2, and this humid air now flows through the reheater. Reheater, again the process is sensible heating, so its temperature increases from T2 to Ts. Okay, so this is the state at the inlet to the conditioned space. Okay, so this hot and humid air flows through the conditioned space, and as it flows through the conditioned space, it takes care of the sensible and latent heat losses. And this line S2O is again your RSHF line for the winter. Okay, so this is your psychrometric cycle, right, for a winter air conditioning system using a preheater. So this is one way by which you can heat and humidify the air. You can also use an air washer and a reheater, and you can again have the same heating and humidification. Let us look at this scheme. So in this scheme you can see that it is almost similar to the earlier scheme, except one difference. That difference is that you do not use any preheater here. Instead of a preheater, you use an air washer. Okay, this air washer directly humidifies the air, right. So outdoor air, again outdoor air and recirculated air are mixed. So the mixed air at condition M flows through the air washer, and in the air washer its humidity increases to the required level, and this humid air now flows through the heater where it is sensibly heated to the required supply temperature S, and this hot and humid air flows through the conditioned space, takes care of the load, and comes out at the conditioned space condition I. Okay, and some part of it is exhausted and the remaining part is recirculated. Okay, so this is another system which does not have a preheater, and this process is shown again on the psychrometric chart here. You have the outdoor air and the recirculated air, both are mixed. So this is the condition of the mixed air. So this process M to 1 is what happens in the air washer. So the humidity increases to the required level, okay, and at this point it enters into the heater where it is sensibly heated to the required temperature S, okay, and at this state it enters into the building, right, and as it flows through the building it takes care of the load, and again this is your RSHF line. Okay, so this is another system. Now preheating of course has certain advantages. What are the advantages of preheating? Preheating of air is advantageous as it ensures that water in the humidifier or air washer does not freeze, and in addition by controlling the heat supplied in the preheater one can control the moisture content in the conditioned space. Okay, that means when you are using a preheater, if this air is let us say very cold, okay, let us say that this air is at minus 20 degrees centigrade, which is possible in cold countries. If this air is very cold, there is a possibility that the mixed air is at a temperature lower than 0 degree centigrade. If it is at a temperature lower than 0 degree centigrade and if you do not use a preheater, in the humidifier water droplets or wetted surface comes in contact with air whose temperature is lower than the freezing point. So there is a possibility that the water may freeze in the humidifier. Okay. So this can be prevented by using a preheater. So in the preheater, since you are using since you are heating the air first, its temperature increases beyond the freezing point, so there won't be any freezing in the humidifier. Okay, so that is the advantage of using a preheater. In addition to that, you can control the heat supply to the preheater. Okay, by controlling this you can control the humidity level in the conditioned space. Okay, so the advantage of using this system. Now the humidification of air can be achieved in several ways. For example, you can humidify air by bringing it in contact with a wetted surface or with droplets of water as in an air washer, or by adding aerosol sized water droplets directly to air, or by direct addition of dry saturated or superheated steam. Okay, so these are the ways by which you can add water vapor to the air. Humidification by direct contact with wetted surface or with water droplets is not recommended for comfort conditions. This is for the same reasons which I have explained earlier, because whenever you are using a wetted surface, there is a possibility of microorganisms growing on the wetted surface, which may give rise to health problems. Okay. So in comfort air conditioning systems for winter, normally wetted surfaces or air washers are not used. Okay, air washers or wetted surfaces can be used for industrial air conditioning systems where human beings are not present. Okay, because of the health problems, right? So for comfort applications, direct addition of dry saturated or superheated steam is generally employed. So that means in winter air conditioning systems for comfort, you always add steam directly to the air stream. Okay. When humidification is carried out by using a wetted surface, then the temperature of air decreases as its moisture content increases. Okay. Now there is a difference between the process line when you are using a wetted surface or when you are adding a dry steam. Okay. For example, when you are using a wetted surface, okay, such as an air washer or something like an evaporative cooler where the air comes in contact with a wetted surface, what happens is water evaporates, okay, and the latent heat of vaporization is drawn from water and air. As a result, the temperature of air reduces. That means the process moves along the or close to the wet bulb temperature line. Okay, so whenever we are using a wetted surface. However, if you are using a dry steam, then you find that the humidification process proceeds close to the constant dry bulb temperature line. Okay. So I can explain this using a psychrometric chart. For example, let us say that this is a psychrometric chart. Okay. Let us say that this is the inlet condition of air to the humidifier, and if you are using a wetted surface, okay, that means this. Then you find that if this is your wet bulb temperature line, the process line may proceed along this or slightly close to this. Okay, so the outlet temperature will be lower than the inlet temperature. Okay, whereas if you are using steam, okay, and if you are using steam, you find that the humidification process follows close to the constant dry bulb temperature line. You know that this is a dry bulb temperature line. Okay. And if the steam is superheated, the exit temperature will be slightly higher than the inlet temperature, right. So this is the difference between the humidification process, which depends upon the way how you are humidifying the air. And for all cases, the exit condition can be obtained by applying mass and energy balance equations across the humidifier. Okay. So, whatever be the process, if you want to find out the exit condition, all that you have to do is you have to take a control volume across the humidifier and apply mass balance and energy balance. Mass balance means you have to account for the mass flow rate of water vapor and mass flow rate of dry air, and similarly you have to account for the energy okay, the rate at which energy is being added is equal to the rate at which energy is being removed in a steady state. So, if you apply the mass and energy balance equation, you can get the value of the outlet temperature and outlet humidity. Okay. And the amount of supply air required, amount of heat to be supplied in the preheater and reheater, amount of steam or water to be added in the humidifier, all these things can be obtained by simply applying mass and energy balance equations across the building or across individual components. Let me explain this. This is very easy. You can for example, I want to find out what should be the supply air flow rate. Okay, I want to find out this. Okay, what should be the supply air flow rate m dot s. Then what I do is I take a control volume across the conditioned space, and suppose from load calculations I know what is the rate at which sensible heat is being lost from the building and what is the rate at which latent heat is being lost from the building. I know QS and QL. Then if I apply energy balance for this control volume, I can write QS like this. QS is equal to m dot s into CPM into Ts minus Ti, where Ts is the inlet air temperature and Ti is the outlet air temperature, and m dot s is the air flow rate and CPM is the specific heat of the moist air, right. And similarly you can write for the latent heat, you can write the energy balance like this. Latent heat transfer rate QL is equal to m dot s into HFG, which is nothing but the latent heat of vaporization of water, multiplied by Ws minus Wi, where Ws is the humidity ratio of the supply air and Wi is the humidity ratio of the outlet air. Okay. Suppose I know Ti from our comfort criteria, Ti is known to me, okay, and Qs and QL are known from load calculations. Then using this equation I can find out and I am also fixing Ts, let us say Ts is fixed based on certain criteria. Then in this equation this is known to me, this is known to me, this is known to me. So, I can find out what is the required mass flow rate. Then what I do is I substitute this in this equation, and again in this equation I know what is the latent heat transfer rate. I also know what is the conditioned space humidity Wi. So, I can find out what should be the required humidity ratio at the inlet to the conditioned space. So, I can find out this. Okay. And once you know what is the required humidity ratio at this point, and if you also know what is the, if these things are known to you, then you can easily find out what is the rate at which heat is to be added in the reheater. For example, take a control volume across the reheater, then heat to be added in the reheater QRH is nothing but m dot into CPM into Ts minus T2, right. M dot is known to me, this is known to me, and the Ts is known to me, and if you know T2, then you can find out what is the rate of heat addition in the reheater. Similarly, you can apply energy balance for the preheater and find out what is the amount of heat added in the preheater, apply mass balance across the humidifier and find out how much vapor has to be added in the humidifier, like that. Okay. In actual winter air conditioning systems, in addition to the basic components, you also have fans or blowers for air circulations and filters for purifying the air. Okay. I have not shown these components in the schematic, but in an actual system consists of these components also in addition to the basic components. Now, let us look at an all year or complete air conditioning system. A complete air conditioning system can be used for providing air conditioning throughout the year, that means during summer as well as winter. The system consists of a filter, a heating coil, a cooling and humidification coil, a reheating coil, a humidifier and a blower. In addition to these, actual systems consist of several accessories such as dampers for controlling flow rates of recirculated and outdoor air, control systems, safety devices, etc. So, let me quickly show a schematic of a complete or all year air conditioning system. So, this is a typical all air conditioning system. This is your conditioned space, and you have a filter for purifying the air, you have a heating coil, you have a cooling and dehumidification coil, you have a reheater. Of course, reheater can be here or it can be here, and you have a humidifier and you have a blower for circulating the air, right. So in winter we require heating and humidification. So in winter you don't have to run this cooling and dehumidification coil. So this is not operational. Okay. So heating coil is on, reheating coil is on, humidification coil is on. So you can achieve heating and humidification, and you can get hot and humid air here during winter, right. Whereas during summer we require cold and dry air. So during summer what you can do is you can switch off this, you can switch off this, you can switch off this, and you run only the cooling and humidification coil, so that you can get cold and dry air at the inlet to the conditioned space. Okay. Of course, the blower is always required, because you have to maintain the air circulation either in winter or in summer. Okay. So this is always on, right. So depending upon the season, the some of the components will be on, some of the components will be off, right. So large systems use blowers in the return air stream also. I have shown a blower only in the supply air stream, but you can also use a return air blower in large systems. And generally during summer the heating and humidifying coils remain inactive, as I have already explained, while during winter the cooling and humidifying coil remains inactive. However, in some rare applications for precise control of conditions in the conditioned space, all the coils may have to be made active. Okay. So rarely you keep all of them active, but it is possible in some applications. And the blowers will remain active throughout the year, as air has to be circulated during summer as well as during winter. And when the outdoor conditions are favorable, it is possible to maintain comfort conditions by using filtered outdoor air alone. That means you can switch off everything and just run the blower. Okay. In which case only the blowers will be running. Okay. And all the coils will be inactive, leading to significant savings in energy consumption. Okay. So when outdoor air is cool, let us say, then you do not have to use any cooling or dehumidifying coils or anything, just run the blower and use full outdoor air and provide comfort. And normally a control system is used in an all air conditioning system to control the changeover. Changeover means you have to change over the system from winter operation to summer operation, or vice versa, depending upon the outdoor conditions. Okay. So a control system will be sensing the outdoor conditions, and depending upon the outdoor conditions it keeps either the summer air conditioning system on or winter air conditioning system on. Okay. So this is all about an all air conditioning system. So let me quickly summarize what we have learned in this lesson. In this lecture we have discussed evaporative air cooling systems, and we have looked at the working principle, different types, advantages, disadvantages, applications, etc. And we have also discussed winter air conditioning systems with and without preheaters, and we have also discussed briefly the schematic and features of an all year air conditioning system or a complete air conditioning system. Okay. So in the next lecture I shall discuss the cooling and heating load calculations. Okay. So with this I stop this lecture. We will continue this in the next lecture. Thank you.